In LR4 Lesson 2, we are going to continue what we are learning in LR4-1. By the end of this lesson, you'll be able to write proofs using the reasoning that corresponding parts of congruent triangles are congruent. Cpctc stands for corresponding parts of congruent triangles are congruent, and you can use this as reasoning. You can either write it out as Cpctc, you could write it out in words, or you could say if triangles congruent, then parts are congruent. Let's just recall that in LR3, we were using these two, naming three congruent parts, and then naming the two triangles congruent based on the three congruent parts that you find. In LR4, we are then taking it one step further, and we're saying this part is congruent to that part because of Cpctc, or congruent parts of congruent triangles are congruent. Or if triangles congruent, then parts equal. All mean the same thing. Let's do some practice here together. So first, let's look at what we are given. We are given GI, which is actually supposed to be GH. So GH is parallel to JI. And you want to make sure you get everything written down, even if you, all the things that were given, even if you're looking at it, you're like, I don't know how I'm going to use that, make sure you have it written down. Let's look at our picture a little bit. When we see parallel lines, the two things we are looking for is either corresponding angles or alternate interior angles. So if we look at GH and JI, these are our parallel lines. We then have a transversal, and our transversal is right here. Okay, HK is our transversal, which, if I look a little more closely, that means I have corresponding angles. Here's angle 1, and here's angle 2. So now we can go back and we can say angle 1 is congruent to angle 2, and this is because they are corresponding angles. And corresponding angles are congruent. Next, we can look at what else we're given, and it says I is the midpoint of HK. So that's side length HK, and that is given. It was written out for me. So since I is the midpoint, I can then go here and say that HI is congruent to IK. And for our reason, we can either say definition of a midpoint, or we can copy our statement from step 3, which said I is the midpoint of HK. Either way is fine. Let's just remember that I had to say I is a midpoint as a statement before I could use it as a reason. That was very important. Similarly, I had to have parallel lines as a statement before I could say that I had corresponding angles that were congruent. We were also given that GH is congruent to JI. Just want to pause for a moment. Notice that we have the GH is parallel to JI and it's congruent. That is not always the case. Just because something is parallel does not mean it's congruent. Just because something is congruent does not mean it's parallel. So be very, very careful. Okay. As I look now, I can see that I have my three congruent parts. I have these angles, I have these sides, and I have these sides. So we've named our three congruent parts. We now need to name our congruent triangles. So I have triangle GHI is congruent. When I name the second one, I have to be very careful. G matches up with J, H matches up with I matches up with K. Our reasoning here is I have two sides, and I have the included angle. So it is side, angle, side. Now, because we've proved that these are congruent triangles, I can go back and see what I was trying to prove. Angle G congruent to angle J. those correspond, and I in fact can say angle G is congruent to angle J, and that is because corresponding parts of congruent triangles are congruent. You could write it like that, you could write it out in words, or you could say if triangles are congruent, then parts are congruent. Any of those ways work. All right, let's take a look at example number 2. In example number 2, the only thing that we're given is that ABCD is a rhombus. All right, so I'm going to go ahead and draw a rhombus. Remember the definition for a rhombus is that it's a parallelogram and all sides are congruent. I'm going to go ahead and label it. What I'm asked to prove now is that the diagonals of a rhombus bisect its angles. All right, so what I'm going to do is I am going to draw in a bisector. And if it truly is a bisector, that means that angle 1 and angle 2 must be congruent. So at this point, what I'm going to do is I'm going to try to prove that angle 1 is congruent to angle 2 by Cpctc. As I'm looking at this right now, I can already say that AC is congruent to AC by the reflexive property. I also can say that, all the sides are going to be congruent. And the ones that I really want to be congruent would be side AB and AD. And side BC and DC. Which we know this is true because all of the sides are going to be congruent to each other. Now, as I look at this, in my two triangles, I can use side, side, side to prove that my two triangles are congruent, which in turn then means through Cpctc that angle 1 and angle 2 are going to be congruent. Which then means because those two angles are congruent, that means that side length AC is going to be a bisector. Now, we did just kind of reason through that backwards, and we're going to use our two-column proof here to reason through it forward. And we have to, of course, start with what we were given. And the only thing we were given is that ABCD is a rhombus. You're always going to want to make sure you write out anything you were given. If for some reason you don't use what you're given, still write it out. Make sure you have everything written out just to be safe. Next, we're going to say that AB, that side length, is congruent to side length AD. And the reason is either definition of a rhombus or all sides of a rhombus are congruent. Next, we know that BC is congruent to DC, and that is the same reason as above. You can either rewrite it, copy and paste, or use the tick marks. Then we can say that AC is congruent to itself, so AC is congruent to AC, and that is because of the reflexive property. Now that we have our three parts, we can say that triangle ABC is congruent to triangle. A corresponds with A, B corresponds with D, C corresponds with C. For this one, we were able to prove it because we had side, side, side. Because we've proved those two triangles are congruent, we can now say that angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent, or Cpctc. In this case, we're not quite done because we were not just sent out to prove that angle 1 is congruent to angle 2. We really needed to prove that the diagonals of a rhombus bisect its angles. Now we can say that AC bisects the rhombus's angles and here you can say it is because it's the definition of an angle bisector, or you can say because angle 1 is congruent to angle 2. We are now done. We've proved that the diagonals of a rhombus bisect its angles. In example 3, we are given that P is the midpoint of LO and MN. What we want to prove is that LM is parallel to NO. If these truly are parallel, then what would happen would be angle L would have to be congruent to angle O. If those two are congruent, because those would be alternate interior angles, then we could say that LM is parallel to NO. So that is what I'm going to try to prove here using Cpctc. Now, without using those angles, I am going to look at what I'm given to prove that these two triangles are congruent. So let's go back to what we're given. We're given that P is the midpoint of LO, which means that this will be congruent to this. And it also says that P is the midpoint of MN, which means that this line is congruent to this line. Notice that it's two different things. Because P is the midpoint of one doesn't mean it's necessarily the midpoint of the other unless we're given that information. Now, as I look at this, I could also see that this angle, we'll call it 1, would be congruent to this angle 2 because of vertical angles. So as I look here now, I can see that I have two sides and the included angle, which means that these two triangles are congruent. Since the two triangles are congruent, I can conclude through Cpctc that angle L is congruent to angle O, which then tells me that LM is parallel to NO because of the alternate interior angles. Now let's go ahead and write this whole proof out. All right, so let's start by writing out what we're given. P is the midpoint of LO and MN, and this is given. Then, because we found that, we can say that LP is congruent to OP. And either you can write definition of a midpoint, or you can say that P is midpoint of LO. Similarly, we can say that MP is congruent to NP, either by definition of a midpoint, or P is midpoint of MN. Next, I want to talk about my third congruent part, which is my vertical angles. So angle 1 is congruent to angle 2, and this is by vertical angles that are congruent. Now, we have enough here. Since we've named our three parts, we need to name our two congruent triangles. So triangle LMP is congruent to triangle L corresponds with O, M corresponds with N, and P corresponds with P. And this is because we have two sides that are congruent and the included angle. So it is side, angle, side. Now, because we know that these two triangles are congruent, we're going to use that last piece, and we're going to say that angle L is congruent to angle O by Cpctc, because corresponding parts of congruent triangles are congruent. We are not quite done yet, because our proof wanted to prove that LM was parallel to NO. So to finalize this, we want to now say that LM is parallel to NO, and the reason for that is we have these alternate interior angles that are congruent. So we can say if alternate interior angles are congruent, then lines are parallel. So once you have proven what you were asked to prove, LM is parallel to NO, then your proof is complete and you're good to go.